I'm Sandy Cowan. I'm the Grease Technology Manager for Citgo Petroleum, and I'm here at the Mystik Laboratories to talk about things that are important for the flow of a grease. So, why is that important? Well, a lot of times we talk about EP, we talk about reducing wear, we talk about improving corrosion, but the reality is the best grease in the world won't work if you can't pump it to the application. So flow characteristics are very important. The first characteristic is one that you probably all heard of. It's often referred to as one of the most important traits of a grease, and that's the viscosity of the base oil that's used. Why is that important? Most of a grease is actually oil. In fact, it's not uncommon for 85% of a grease to be the oil. So the oil selection can be something with a low viscosity that's going to flow very easily, or a higher viscosity that's going to carry loads. All of these affect the pumpability, particularly when the temperature changes. Higher viscosity oils can, in some cases, significantly increase in viscosity at low temperatures. So choosing a base oil viscosity that's appropriate for the application is very important. Another trait of grease that's important when considering how well a grease flows or doesn't flow is the grease consistency or hardness. So there are greases that literally will pour from a container. These are often referred to as semi-fluid greases. They're often selected for applications that are in very cold temperatures. And there are other applications where it's just important that you just use a semi-fluid grease. But you can also have a grease that's the total opposite side of the spectrum. This is referred to as a brick or a block grease. And as you can see, I can literally hold this grease in my hand. It's called a block grease because in the application it's also often cut into a block or brick-like shape. And then it's just applied to the application by rubbing the grease across the surface. The last characteristic of a grease I'd like to talk about that impacts its flow is one that you may not have heard of. There are fluids that are called Newtonian, and then there are fluids that are called non-Newtonian. A Newtonian fluid is one that does not change viscosity as the force or the shear stress changes. Examples would be something like water. For example, if I had a bowl full of water and I were to apply a rapid force to that surface, you're not going to see the water immediately harden or thin. I can slap the water's going to splash everywhere. It does not change in viscosity. There are other examples of fluids that are Newtonian. Those would include things like straight mineral oils, or milk, or for that matter, air. As you drive your car through the air, you don't see the viscosity of the air change. Grease, however, isn't Newtonian. It's in the category that's referred to as non-Newtonian. And as you might imagine, these do change viscosity as the stress is applied. If you're like me, you remember when we bought ketchup in glass bottles. And so it wasn't uncommon to try to put some ketchup on your French fries and you tap on the bottom, nothing happened, you tap harder. And then finally you'd hit the back of the bottle very hard, and what happened? Half of the bottle ended up on the French fries. Well, ketchup's called non-Newtonian, and it has the characteristics of when it reaches a certain stress, it actually reduces in viscosity, which is why so much ketchup came out of the bottle at one time. There's a real good reason they're sold in plastic bottles today. Other examples include quicksand or Oobleck. Oobleck is a term from a Dr. Seuss book. It's actually a name used today for a mixture of cornstarch and water, which is what I have here. So it's just this mixture, cornstarch and water, and it has odd characteristics in that if it's under pressure, it's a solid, but if I take the pressure off, it becomes fluid. So unlike water, if I slap the surface, I'm going to apply a rapid shear stress, and the viscosity, even though you can see this, definitely would pour, the viscosity is going to increase. So I can't make it splash out of the container because the rapid stress that I'm applying is causing the viscosity to increase. Now, having said that, let's say I have some in a fist, it's a solid, I reduce the pressure, it becomes a liquid, it becomes fluid again. So this is an example of a non-Newtonian fluid and what they do. Greases change viscosity as the pressure or the shear force changes. So in summary, what are the factors that can affect the flow characteristics of the grease? Number one, the viscosity of the base oil that you use. the hardness of the grease, whether it's a semi-fluid, something in between, or a brick grease. And lastly, the fact that grease changes viscosity as the shear force changes on it. If you'd like more information on flow characteristics of grease or help in selecting the right grease for your application, please visit mystiklubes.com and visit our Resource Center.